Welcome back. Now I will briefly introduce you to clustering. So according to Wikipedia, cluster analysis or clustering is the task of grouping a set of objects in such a way that objects in the same group, called the cluster, are more similar in some sense or another to each other than those in the other groups, in other clusters that is. So we are working with textual data, and now we are happy with our data. We have removed enough stop words and we are ready to proceed with the analysis. So in text mining, documents have been turned into a set of numbers. So we have the document term matrix. This document term matrix can now be clustered. What two clusters exist in below with documents A, B, C, and D? We can assume that we have 3 words in each document, which we have not given any names, but we see that in A, the first word appears 4 times, the second word once, and the third one 0. So, if you would to perform a cluster analysis, which of the 2 clusters would you form from these documents? Please consider this for a while. Okay, now I will provide you with the answer. So if we look in the documents A, B, C, and D, we can see that A and C are quite similar. They both have a high number in the first column, so they both contain 4 times the first word, and C has 3 in here. With respect to the second word, there is some commonality, but it is not such a commonality that it would separate it from B and C. So we can see that the most of the commonality actually comes from the first word, where C has 3 and A has 4, while B and D have zeros. And the other cluster is now obviously B and D, that have 3 and 5 for the last word, whereas C and A only have zeros. Okay, now back to R. So now we have iterated our document term matrix enough that we are happy and can start producing analysis. So we will start from line 73 and we will simply execute everything until line 92. This creates a dendrogram clustering file and saves it as a PDF so it can be inspected. Okay, so it appears that the computation is a bit slow. It might also take some time in your computers. Okay, that computation took too long, so I was forced to restart. Let's just select everything, initialize file, and hit execute. Now I hope that everything is well. Then I go back to the DTM and dendrogram clustering. And I execute that as well. And I select it all the way to line 46. And at this point I realized that there's actually a bug in line 46. So it says stop words true, but it doesn't select stop words that should be used. So we should actually always include my stop words in there. I fixed this line 46. This should work. Now we are using the my stop words, which is the one we have created here in a bar. We are creating the document term matrix in here. We need to have this line corrected. Okay. Now I hit execute and hope everything works well. It does. And I have ended up with the document term matrix that I now want to analyze with clustering techniques. If I jump a bit lower, there is another block that does stemming. But stemming might not actually improve the result, so I'm going to skip stemming for now, and I continue on line 68. And I only select 500 papers for this analysis in order to get faster computations. I think in the original source code you actually have 200 papers, but you should edit this number accordingly. So I select 500 papers for the analysis, and this means that also further down in the file I have to select the 500 titles that are here. So I also need to use this plotting line instead in line 92 instead of line 90. So now I execute these lines and I hope I get some results in, let's say, less than a minute. Okay, indeed it took less than a minute. So 500 appears to be a good number for this data set. Now let's see the results. Okay, and we can see that in my data location I now have a file pdf scopus tse articles clean data.pdf, which is the file I just created on R. Now I open this up, and what we can see are the 500 article titles that were selected for the cluster analysis. It is not very easy to view this, but we plotted this as a PDF so that we can zoom in and see what's inside here. Now we can actually see the article titles that are available. But let's first turn this around from here, and now we can maybe see something. We can see some clusters. Okay, there is a one cluster over there. So this is a tree type of clustering thing. So the elements in the same branch are always more similar to one another. So if we zoom in here, we can see that we have several articles titled State of the Journal. These are basically articles where the editor-in-chief says where is this journal heading, what type of papers were published, and so on. So they are all very similar, and in this sense the clustering works quite nicely as they are all connected to one another. I mean, they're close to each other here. State of the journal, also in here, in a bit lower. Also above here. And then we have editorial from new editors. So this is basically the editorial office sending some message to the community. And if we jump to the very top, we can see that we have papers that talk about testing. First one is automated test case generation. Then there is a paper about the prioritized test cases, test case prioritization on the line 3 again. On line 4, using dependency structures for prioritization of functional test suites. Line 5, regression testing. Testing from partial finite state machines without harmonized traces, and so on. So we can see that the testing papers are clustered on the top part here. Okay, so what we conclude here is that dendrogram clustering gives you an intuitive clusterings that you can zoom in. We can see all the 500 papers in here, but it does not scale very well. So if you have 500 papers or 500 tweets, the clustering works quite okay. But when you have thousands, it might be problematic to get the clustering to compute in a time that you would be willing to wait for. But for a certain type of dataset, this gives, you know, an easy way to explore the clusters and the text that you have collected. Okay, now let's finally take a peek on how the progress in exercises so far maps to the trend mining report you need to produce in the end. So you can see the reporting structure from Noppa. And what we have so far completed is search strings. You should have search strings for all 3 data sources: Twitter, Stack Overflow, and Scopus. They might be the same, but there might be some small differences between sources. You should also have the stop words for all the 3 datasets from 3 different sources. Again, the stop words might be same, for all of them, but there might be small differences between sources. Finally, you should have concluded the dendrogram and the hierarchical clustering for all the 3 sources. And in the upcoming weeks, we will look into how to make word clouds, how to analyze top 5 popular sources, interactive clustering, and hot and cold topics with LDA clustering.